Bismillahirrahmanirrahim. So today we will see the problems in problem sheet 2. Okay, so the first problem, actually this has been taken from Leon Garcia, and the first problem is from the chapter 4, the first problem 4.1. So anyway, the question is, you have a information source which is producing a set of random numbers. You can see this random numbers are denoted as, actually it is 1, 2, 3 and 4. Okay, and it is having the probabilities as mentioned in the first case. Okay, the probability is pk. It has been mentioned that the probability is pk, which is nothing but it is p1 over k. So we can define all the probabilities. That means we have this sample space. You can see here 1, 2, we have the random variables 1, 2, 3 and 4. Now this 1 is having the probability, it is nothing but p1, and p2 is having the probability, it is nothing but p1 by k. Okay, so that means p1 divided by k is equal to actually 2 here. Next the third one is having the probability p1 divided by 3, because k is 3 here, and p4 is nothing but p1 divided by 4. Okay, now we want to find what is the probability for each event. So you know that if you add all the probabilities, sum of all pi, that will be equal to 1. That means it is nothing but p1 plus p1 by 2 plus p1 by 3 plus p1 by 4. This will be equal to 1. If you solve this equation, you will get p1 as 12 over 25. Okay, then you can find p2 as p1 by 2, which is nothing but 12 over 25. You have to divide it by 2. Okay, similarly you can find p3 as p1 by 3, which is nothing but 12 over 25. You have to divide it by 3, and you can find p4 as p1 by 4, which is equal to 12 by 25 divided by 4. Okay, this is how to find all the probabilities. Now you can the first part of the question. Okay, I will solve only the first part. Actually, first part means I will solve only this part. Okay, the other things are also following the same procedure. You can follow the same procedure that I am showing for the first part. Okay, so we will see now part A. What is part A? Plot the CDF of this random variable. So we have to plot the CDF. Okay, so we have to plot the CDF of this random variable. So you can see here what is our p1. I will rewrite it again. Our p1, you will get it as 12 by 25. Okay, then you will get p2. If you substitute it, you can see here it is nothing but p2 is equal to 12 by 25. Okay, and you have to divide it by 2, so it is nothing but 6 by 25. Okay, so if you substitute, you will get 6 by 25. Similarly, you will get p3 as 4 by 25, and you will get p4 as 3 by 25. Okay, if you substitute all this value, because pk is equal to p1 by k. That's why this is what our formula. That's why. So we can have the cumulative distribution function. That means the probability, the fx of we have our outcomes xx is equal to 1. Our random variables are 1, 2, 3 and 4, right? Then fx of 1 is nothing but the probability that x takes the value less than or equal to 1. It is nothing but 12 by 25. Okay, similarly fx of 2 is nothing but the probability that x takes the value less than or equal to 2 is nothing but 12 by 25 is already there. Okay, because p1 is there, it is, then you have to add p2 also, because you are talking about probability that x less than or equal to 2 is nothing but the probability that x is equal to 1 plus the probability that x is equal to 2. So it is nothing but 12 by 25 plus 6 by 25. Okay, so you will get it as 18 by 25. Similarly, fx of 3 you can get it as it is nothing but 12 by 25 plus 6 by 25 plus 4 by 25. Okay, so this you will get it as, I think it is 22 by 25. Okay, and fx of 4 you will get it as fx of 4 is nothing but you have all the outcomes, that means 12 by 25 plus 6 by 25 plus 4 by 25 plus your last one 3 by 25, which is nothing but 25 by 25. That means it is nothing but 1. That means sum of all probabilities will be always 1 anyway. So this is what the cumulative distribution function. So all these are representing the cumulative distribution function. So we can actually basically draw it anyway. So this is what you have, 1 2 3 and last one it is 4. Okay, now this we have got it as 12 by 25. Okay, we have got it as sorry, this was from 1 onwards. Okay, so from 1 onwards we got it as 12 by 25, and this will continue till 2, and at 2, from 2 onwards we got it as 18 by 25, and it will continue up to 3, and from 3 onwards we will get it as 22 by 25, and from 4 onwards we will get it as 1. Okay, so this is what the cumulative distribution function, which is fx of x. Okay, fx of x. Okay, so this is the cumulative distribution function. So this is the first part of the problem, and next the part B is there for the problem. So this is part A anyway. I will denote, I will show it as part A anyway. Now we have part B for the problem. Okay, what is part B? The part B of the problem, I will read the question. Use the CDF to obtain the probability of the events x less than or equal to 1. That means you have to find fx, the probability that x less than or equal to 1. That means fx of 1, it's by definition. Fx of 1 is nothing but 12 by 25 from the graph. Okay, the next part is you have to find what is the probability that x less than 2.5. X less than 2.5 means the probability that x less than 2.5. Okay, 2.5, which is nothing but the probability that there are only two values, x is equal to 1 and probability that x is equal to 2, which is less than 2.5. Okay, so this is nothing but, it is nothing but 18 by 25. You will get it as 18 by 25. Next part is you have to obtain what is the probability that x is between 0.5 and less than or equal to 2. Okay, so it is nothing but the probability that x takes the value between 2 and 0.5. That means if you take these points, you can see here your 0.5 is here, 0.5 is here, okay, 0.5 is here, and if you consider this 2, this is your 2. Okay, so it is nothing but you have only one value. That means it is nothing but the probability that x is equal to 2, because you have only one value. Okay, so that is nothing but you will get it as x is equal to 2 is nothing but, you have already got it, it is nothing but 6 by 25. Okay, because there is only one value, because 1 is not included, you need only in between the 0.5 and 2. So 0.5 will be here, so it is including 2, that's why. So see here it is including 2, that's why we are considering the probability for 2. Next it is the x between 1 and 4. Okay, between 1 and 4, but not including 1 and 4. So the probability that x is between 1 and 4 is nothing but, you cannot include 1 because it is not including 1 here, it is just is greater than 1 only. So you can see here it is nothing but the probability that x is equal to 2, and there is only one thing, that means probability that x is equal to 3. So what is x is equal to 2? The probability for x is equal to 2 is we have already seen it. P2 is 6 by 25 and 4 by 25. That means it is 6 by 25 plus 4 by 25, which is equal to 10 by 25. So that's the answer. So you can solve all this problem in the same way for the second part of this. Okay, for example, if you are considering the second probability, you can see here the second probability is, second part is p of k plus 1 is nothing but p of k divided by 2. Okay, p of k divided by 2. So the first part, you have all the outcomes, all the random variables as 1, 2, 3 and 4, and let's say this is p1, then p2 will be equal to, okay, pk, that means p1 divided by 2, that's it. And next p3 will be equal to p2 divided by 2, that means it is again p1 by 2, you have to divide it by 2, that's it, because p2 is equal to p1 by 2. So this is nothing but p1 by 4. Okay, next is p4. Okay, p4 is equal to p3 by 2, and what is p3? P3 is p1 by 4, you know, then you have to divide it by 2, it is nothing but yes, it is p3. Okay, so I think it will be equal to p1 by 8, right? Yes, p1 by 8. So you got all the probabilities. One is p1, another one is p2 is equal to p1 by 2, and another one is p1 by 4, and you got the last one as p4. P4 is nothing but p1 by 8. Okay, so you got all the probabilities. Now you add all these things, summation of all pi's, which is equal to p1 plus p2 plus p2 is nothing but p1 by 2 plus p1 by 4 plus p1 by 8. This will be equal to 1. Then you can obtain p1 from this equation, obtain p1 by solving the above equation. Okay, then you can find all the probabilities, and you can use the same procedure that I have used in the previous part of the problem. Okay, so that's all. Now I will also show you the third part. Okay, third part also you proceed as in the previous part A, proceed as in A and B. That means A and B means this is the part B, you can see, and this is the part A. So you can follow the same procedures, only the values will be different. Okay, now we will see the 3. Actually in part 3, actually the PDF has been defined with another formula. P of k plus 1 is equal to P of k divided by 2 power k. Okay, so we have xx is equal to 1, 2, 3 and 4. Okay, now this is the first, this is for k equal to 1, and this is k equal to 2, and here actually k equal to 3, and this is k equal to 4. Now the first one will be p1. Okay, p1 will be is equal to p1 will be equal to pk by 2 power k with k equal to 1. That means it is nothing but p1 by 2. Okay, that's it. Okay, the first one, okay, p of k plus 1, sorry, p of k plus 1 is nothing but p of k plus 1, sorry, this is, I have made a mistake here. So is p of k plus 1 is pk by 2 power k. So let us assume that the first probability is p1, then p2 will be equal to p1 divided by 2 power 2, and p3 will be equal to 2 power 2 power, not 2 power 2, 2 power 1 actually. This is p, this is k equal to 2, so you have to use here k equal to 1 here. Okay, this is nothing but k equal to 1. You see, this is k plus 1 and this is just k. Okay, now p3 is equal to p2 divided by 2 power 2, which is nothing but p2 is equal to p1 by 2. Okay, then whole divided by 2 power 2. Okay, so this p3 will be equal to p1 by 8. Okay, that's it. Next is p4. P4 is equal to p3 divided by 2 power 3, I think so. Yeah, 2 power 3, and p3, you know, it is p1 by 8. Now you have to divide it by 2 power 3. 2 power 3 is nothing but 8. So this p4 become p1 by 64. Okay, so you got all this p3, you got p4, p3, and you got p2. Okay, and you know what is p1. So you have all the probabilities, sum of all pi's for all i's, that will be equal to 1. So you can use this equation and solve and obtain what is the value of p1, how much, p2, p3, and p4. After that, follow the same procedure. Okay, follow the same procedure. Okay, same procedure. This I am not going to solve this completely. Okay, so I hope this problem is very clear to you. Okay, so we will see next problem. So this is the second problem which is shown in our problem sheet 2. You can see here, let y be the difference between the number of heads and number of tails in a 3 tosses of coin. That means you are tossing the coin, you are tossing the coin 3 times. Okay, let us assume that the number of times you are tossing the coin is n. So n is actually denoting the number of times. That means the total number of times. Total number of times you toss the coin. Okay, that's it. So we have n. Now the number of heads, let's y be the difference between, y is a random variable, okay, which is showing the difference between the number of heads and number of tails. This is nh minus nt. That means this is the number of heads and this is the number of tails. Okay, so since you are tossing the coin 3 times or n times, in general you are tossing the coin n times, the number of tails will be nothing but total number of trials minus number of heads. That's it, right? If you are getting since you are suppose you are tossing the coin 3 times and you are getting 2 heads, that means you are getting 1 tail. That means it is nothing but 3 minus 2. So we can write like this, our random variable y as nh minus number of tails means total number of trials minus number of heads. So this is equal to nh minus n plus nh. So your random variable y will be 2 times nh minus n. Okay, this is your random variable. Now we know that we have our n equal to 3. Okay, so since we have n equal to 3, we can have different possibilities for number of heads. So number of heads can be 0. We cannot get any head also. We may have a chance that we have no heads, or we can have 1 head, or we can have 2 head, okay, or we can have 3 heads. So these are all the possible choices for head. So our random variable y, what is our random variable? Then what will be our value for y? So our random variable y will takes the values, okay, which is a function of nh. Actually this y is a random variable. We are talking about the random variable y, which is actually a function of nh because it will depend upon number of heads. So if we get no heads, that means 0 head, we can get one head. Okay, y is a function of nh. Anyway, I will show you. But what is nh? Nh can take the values. It can be, as I have told you here, it can be 0, it can be 1, it can be 2, or it can be 3. And our n, I think we know that n is equal to 3. That means the total number of trials has been given. So this is n equal to 3. So what will be our y of nh? So that's what we are going to write it. So I am going to show it in a table. So y of nh will be, this is our nh. So y of nh means our random variable. Okay, so our random variable nh, y of nh will be what? So first n is equal to 3. So you can use this formula. If n equal to nh is equal to 0, so then it become 2 into 0 minus 3. So this become minus 3. Okay, minus 3. Next, when nh is equal to 1, you can have 2 into 1 minus 3, which is equal to minus 1. So it will take the value minus 1. When nh is equal to, so another one, when nh is equal to 2, you will get 2 into 2 minus 3, which is equal to 1. So it can take the value 1. And another, see here, and you can get one more thing. When nh is equal to 3, then you will get it as 2 into 3 minus 3, which is equal to 3. Okay, so you can get 3 also. Okay, then what are all the probability? What is the probability of y? That we have to find. Okay, what is this? What is this? And here. Now I think you now understood what is this new random variable y. So we will see here, y of nh will take the values minus 3, it takes the values minus 1, it takes the value 3, 1, and it will take the value 3. And what is our nh? Nh will take the value 0, 1, 2, and 3. Now we are talking about our probability mass function. Okay, we will talk about the probability mass function for the nh, for y. Okay, now listen carefully. You see here, y become minus 3 due to the fact that nh is equal to 0. So what is the probability that nh is equal to 0? That means number of heads. The number of heads, that means number of heads, the probability that number of heads is equal to 3, and the total number of heads is equal to 0, and the total number of trials is equal to 3. It is following which kind of distribution? It is following the binomial distribution. That's what we have seen. Okay, if you are tossing a coin 3 times, then you can get like this. That means it is nothing but n choose k. You remember this, so it is n choose k, n choose nh. Okay, then it is nothing but the probability that, okay, we will assume that the probability of head is equal to probability of tail is equal to 1 by 2. It is given. Okay, sorry for this. So it is probability of head into, probability of head is p into p power nh into 1 minus p whole power nh. This is the probability. This is according to the binomial distribution. So this is nothing but 3 choose 0 into probability of nh, the probability of not nh, the probability of head, okay, probability of head is 1 by 2, and how many heads we are getting? We are getting nh heads, and our nh is equal to 0. So 0 into 1 minus p the whole power, that means 1 minus p is again 1 by 2. So 1 by 2 power n minus nh. Okay, n minus nh, that's what, n minus nh. Okay, that is known as the binomial distribution. So it is nothing but 3 minus 0. So you will get it as 3 factorial divided by 3 factorial into 0 factorial. okay, into 1 by 2 whole power 0 into 1 by 2 the whole power 3, which is equal to 1 by 8 anyway. So you will get this probability as 1 by 8. Now the probability, so the probability of minus 3 is nothing but the probability that nh is equal to 0. Now the probability of minus 1 is nothing but the probability that minus 1 is coming directly from nh is equal to 1. So nh is equal to 1, that means it is nothing but 3 choose 1, 1 by 2 the whole power 1 and 1 by 2 whole power 3 minus 1. So again this become 3 factorial divided by 3 minus 1 factorial into 1 factorial into 1 by 8. Okay, so this become 3 by 8 anyway. So you will get this probability as 3 by 8. Now the probability of this 1 is nothing but the probability that nh takes the value 2. That means it takes the value 2 because it is directly coming from nh. So you see here it is 3 choose 2, 1 by 2 power 2, 1 by 2 power 3 minus 2. So you will get this as again 3 by 8. Okay, so the probability of 3 now, 3 is nothing but the probability which is that n coming from n is equal to 3. So this is nothing but 3 choose 3, 1 by 2 power 3 into 1 by 2 power 3 minus 3. You will get it as 1 by 8. Okay, so you got all these things. This is 3 by 8 and this is 1 by 8. So you got all the probability. Okay, so the first part is over. The first part is not over anyway. You have to plot the cumulative distribution function. So I am going to find the cumulative distribution function. We have many values for the random variable. That means minus 3, minus 1, 1 and 3. So fx of minus 3 is nothing but, just take the probability, that means it is 1 by 8. Now fx of minus 1 is nothing but, you have 1 by 8 here and you have 3 by 8. That means 1 by 8 plus 3 by 8, which is equal to 4 by 8, which is nothing but 1 by 2. So fx of I think what is it, fx of 1 is, you have to take all the probabilities. That means 1 by 8, 3 by 8 and 3 by 8. So 1 by 8 plus 3 by 8 plus 3 by 8, which is equal to 7 by 8. This is the probability. This is the cumulative distribution function. Now fx of 3 is nothing but, you are adding all the probabilities. That means it will be equal to 1. You will get it as 1. Okay, now you can plot the cumulative distribution function for this random variable y. That means not fx. Okay, sorry, this is a random variable y. Okay, we are talking about the random variable y. Okay, sorry for this. So fy of y, and y takes the value from minus 3 onwards, minus 3, minus 1, this is plus 1 and 3. Okay, minus 3, before minus 3 actually it was 0, the value was 0. Before minus 3 the value was 0, and minus 3 to till the left side of minus 1 it was 1 by 8, and from minus 1 onwards it will become 1 by 2, and it will continue till 1, and at 1 its value becomes 7 by 8. Let's say I will show here. So it's become 7 by 8, and at 3 it become 1. Okay, so this is our fy of y. Okay, so this is our y. Okay, which is a function of nh. Okay, so this is known as, this is the cumulative distribution function for our random variable. I hope this is clear to you. Now we have to find, we have to express, the second part of the question is to express the probability that the modulus of y less than or equal to y in terms of the CDF of y. Okay, so what is it? You know that the probability, so this is the second part B, and this was the solution for actually part A. So we were solving this for part A anyway. Now the probability that absolute value of y takes the value less than or equal to y, we have to express this in terms of the density, the cumulative distribution function. But you know that the cumulative distribution function, if I use the cumulative distribution function, the cumulative distribution function for y is usually given as fy of y, which is nothing but the probability that y less than or equal to y, right? But we need this guy, the probability that absolute value of y is less than y. There is no equality sign there. So that is a problem. Now we will see here what to do with this. So this is nothing but the probability that the random variable y takes the value, okay, the probability that the random variable y takes the value less than y and minus y. That means takes the value between y and minus y. But if it was like probability that y takes the value less than or equal to y and minus y, if it is a equality sign as shown here, then we can write it as fy of y minus fy of minus y. There is no issue. But here you see here there is no equality, both equality, actually no equalities are there, so we can, no equalities, okay, so we can we have to take the point just left side to y, okay, then only we can express in terms of the cumulative distribution function. So if you take the point y, the left side is nothing but y minus. If you take the point minus y, the left side is minus y minus left side, okay. You know this notion. If I consider 0 minus means just immediate neighbor of 0, but it is left side of 0, and if it is 0 plus, if it is right side of the 0. So if you are taking a point y here, y minus means just left side of 0, y, okay, that's it. Now that's what we want. So we can express our probability that absolute value of y less than or y as the probability that y takes the value between y and y minus, sorry, not y minus, minus y. So this can be written as fy of y minus, why I am using y minus, because there is no equality here, that's why it's only just less than, minus fy of minus y minus, that's it. So this is the answer. So this is how to represent this probability in terms of the cumulative distribution function, okay. That's what the question, how to represent in terms of cumulative distribution function. I hope this problem is very clear to you. So next problem is basically it is a function of a random variable, okay. Now you can see here you have a random variable x which is equal to 1 minus zeta all power minus 1 by 2, and this zeta is already given as a random variable which is uniformly distributed. So zeta is uniformly distributed random variable in the interval, in the unit interval, okay. What is that unit interval? Unit interval means it's 0 and 1. So it is a uniform distribution. So zeta is a random variable which takes some, zeta is a random variable. So f zeta of zeta, actually I can show like this. is a random variable uniform distributed between 0 and 1. Now you know that this width is 1, so this height should be also 1, so its value is 1 here, okay, because area is equal to 1. Area under PDF is always 1, that's why. So we have this random variable, we know the characteristics of zeta, we know this characteristics, then what is the situation for x, okay. So first of all, the first part of the question is to sketch the x as a function of zeta, okay. You can see here, if zeta is equal to 0, if zeta equal to 0, then x will be equal to 1 minus 0 whole power minus 1 by 2, which is equal to 1, okay. And you can see that this is a nonlinear function, so it will be going like this. If you sketch, it will start from at value 0 when zeta equal to 0. When this is zeta, when zeta equal to 0, it will be having a value 0, and when zeta equal to 1, it become 1 minus 1. So we will see what is the situation when zeta equal to 1. So when zeta is equal to 1, this means that 1 minus 1 the whole power minus 1 by 2, it is nothing but 1 by 0 power 1 by 2, it is nothing but 1 by 0, which is equal to infinity. So at 1, it is, this guy is going to infinity, basically infinity. So this is a nonlinear function which is going to infinity at this point. So this is the function, okay. Now if you consider any small x, there will be a zeta star, you can say something like this. So this is x of zeta. So this is the function. So the function is going to infinity as it goes to 1, when zeta goes to 1. So this is what the function. Now we have seen the first part of the problem, that means to sketch. Now we will see the second part of the problem, that means the CDF. We have to plot the CDF of x. You know this, we have to plot the CDF of x. You know that x is equal to 1 minus zeta whole power minus 1 by 2, which is nothing but 1 by 1 minus zeta whole power 1 by 2, which is nothing but 1 by square root of 1 minus zeta, okay. This is your function. Now what is the cumulative distribution function of x? So cumulative distribution function of x is nothing but fx of x, which is nothing but the probability that x takes the value less than or equal to x, and this is equal to probability that, what is x? X is nothing but 1 by square root of 1 minus zeta, okay, less than or equal to x. So this is equal to the probability that you square it, 1 by zeta is less than or equal to x square. Just square both sides, here and here you square it, then you will get this answer, okay. So this is nothing but the probability that you take the reciprocal now, so you have to take the reciprocal here also. So this sign will change, this will change. So this is nothing but 1 minus zeta greater than or equal to greater than or equal to 1 by x square. So this is nothing but the probability that minus zeta is greater than or equal to 1 by x square minus 1. So again I am going to multiply with minus 1 on both sides, so again the sign will change. So this is nothing but zeta less than or equal to, because I will change the sign, because I am going to multiply with minus 1 on both sides, so sign will change. So 1 minus 1 by x square. So this is the probability, okay, fx of x. So what is this? It is nothing but integral 0 to 1 minus 1 by x square f zeta of zeta, because we are talking about zeta here on the right side, d zeta, okay. So this is equal to 1 by, what is f zeta of zeta? We know that this value is always 1 here. So it's 1 integral 0 to 1 minus 1 by x square into d zeta. So if you substitute the limit, after integration you will get zeta, and you substitute the limit 1 by 1 minus x square. So you will get the answer as 1 by 1 minus 1 by x square. Okay, so this is the cumulative distribution function for the x. So the random variable x is having the cumulative distribution function 1 minus 1 by x square. Okay, so you got it, the cumulative distribution function. Now if you plot it, you know that your x takes the value when zeta is having the values from 0 to zeta is 1. Then your x, which is nothing but 1 by square root of 1 minus zeta, it is nothing but, if you know this function now, what is when zeta equal to 0, it will be 1, and when zeta equal to 1, it will be infinity, right? So it is starting from 1. So your x start from x is equal to 1 and x is going to infinity anyway. So this is your x axis, and this is the function 1 minus 1 by x square. It will be looking like this. So this is, and it will be finally going to 1 as it goes to infinity. Okay, so this is going to 1, and this is your fx of x. Okay, now other part of the question. So this is over. So we have plotted the we have to plot the CDF. That's what we have done now. Now we will see the third part of the question. Find the probability of the events that x greater than 1. The probability that x greater than 1. This is the first part. What is this? It is nothing but 1 minus the probability that x less than or equal to 1, right? That's what. Because the total probability is 1, so it is nothing but the probability that x less than 1 minus the probability that x less than or equal to 1. So this is nothing but 1 minus fx of 1, right? So it is 1 minus, because this guy is nothing but fx of 1. Okay, so you got it as 1 minus 1 by 1. So you got it as 1. Okay, so the probability that x greater than 1 is 1. Okay, now we have the second part. What is the probability that x is between 5 and 7? So you can see this is a continuous random variable. The above one is a continuous random variable. So for continuous random variable, the probability that x less than or equal to small x, it is nothing but the probability that x less than x, both are same, because at x is equal to x, the probability is equal to 0. That's why this is nothing but fx of x, because the probability that x takes the value x, if you are considering a single event, that is having a probability that is equal to 0. That's why. Okay, so that is not a so this is what the notion that you have to remember. So we have to find something. So this is very important concept. So we have to find, according to the problem, we have to find something like what is the probability that it is between 5 and 7. Okay, so probability that x takes the value between 5 and 7, it is same as the probability. This is the question. So it is same as the probability that x takes the value less than or equal to 7 and 5, because it is a continuous random variable. That's why. Okay, in discrete you cannot use like this. Now this is nothing but fx of 7 minus fx of 5. Okay, so you can find it as 1 by 7 square, that means 49, minus 1 by 5 square is 25. So you will get the answer as 1 by 25 minus 1 by 49. Okay, so this will be equal to 0.01959. so please cross check this answer calculation. Okay, the method is correct. Now what is the last part of the question? Yeah, what is the probability that x less than or equal to 20? Now we will see the probability that x less than or equal to 20 is nothing but fx of 20. So this is nothing but 1 minus 1 by 20 square, which is equal to 1 minus 1 by 400, which is equal to 0.997. So this is how to solve this kind of problems. Okay, so for my conclusion is that this is very important point. For continuous random variable, fx of x is nothing but probability that x takes the value less than or equal to x if the function is continuous. Okay, for continuous, this is nothing but probability that x less than x plus probability that x is equal to 0, x is equal to x, but this for a continuous is usually 0, because there is no meaning, as we have seen in the lecture 2 when we explain about the sigma algebra and all. So this is nothing but the probability that x less than x. So for continuous random variable, fx of x is nothing but the probability that x less than or equal to x, which is nothing but the probability that x less than x. So both notions are same. Okay, but for discrete random variable we cannot consider like this. Okay, for discrete we cannot consider like this. Okay, I hope this problem is very clear to you. So next we will see another problem. This is the next problem. Okay, you can see here a random variable x is uniformly distributed in the interval minus 1 to 2. So we have a uniform distribution. Between minus 1 and 2. So we will see now. So x is the random variable. So x is uniformly distributed. So we have fx of x, and this is x. So it is ranging from minus 1 to 2, and it is uniform, so it's constant everywhere, and this is a uniform distribution. Now you know we have to find what is this amplitude. Okay, what is this amplitude? So you know this width is 2 minus 1, which is equal to 3. So this amplitude will be 1 by 3, so that the area will be 3 into 1 by 3 will be equal to 1. That's why. So we got the fx of x. So fx of x is equal to 1 by 3, where x takes the value between minus 1 and 2. Okay, this is what the cumulative, so this is what the PDF. Now we want to find the cumulative distribution function fx of x. Fx of x is equal to, this is the part A of the question, fx of x is nothing but integral minus infinity to x fx of x dx. Okay, but you can see here I am using the variable x, so it is not a good notation, so I will use the t. So this is minus infinity to x, and fx of t is nothing but 1 by 3 into dt, which is equal to 1 by 3 into t and minus infinity to x. So minus infinity to x. So our integral is not actually starting from minus infinity. You can see that our integral is starting from minus 1. So I will change this limit, this as minus 1 to x fx of t dt. So this is minus 1. So again this one is also minus 1. Okay, so this is nothing but 1 by 3 into x minus 1. Okay, x minus 1. That means I will write the steps. So this is, I will put t is equal to x, then minus, then you have, I will put t equal to minus 1. So this will be fx of x will be equal to 1 by 3 into x plus 1. Okay, This is what the cumulative distribution function. Okay, now we will plot it. You can see that our fx of x is equal to 1 by 3 into x plus 1. This is in the form of ax plus b. That means this is like 1 by 3 into x plus 1 by 3. That means this is equal to ax plus b form. So what is a here? A is 1 by 3, which is nothing but the slope of the curve, and b is the y-intercept, which is again 1 by 3. So I will plot it, your fx of x, which is changing from -1 to 2. So you can see here, this is a straight line equation. So at x is equal to -1, fx of x will be equal to 1 by 3 into -1 plus 1, which is equal to 0. So this value is 0. Y value is 0 again. Now at x is equal to 2, fx of 2 will be equal to 1 by 3 into x is equal to 2, 2 plus 1 is equal to 3. So 1 by 3 into 3, which is equal to 1. So at 2, the value is 1. So this is a straight line equation, as I told you. Sorry, my drawing, there is some issue with my drawing. That's okay. This is equal to 1, and from 1 onwards it will be a straight line. You see here that it has reached 1, then after that it will be a constant. I told you about this thing before, because yeah, now this is the curve, 1 by 3 into x plus 1, and this is the x. Okay, now what will be this point? How much will be this crossing point? You see here this is x is equal to 0. When x is equal to 0, 1 by 3 into 1, so this value will be 1 by 3. Okay, so the probability that x less than or equal to 0 is 1 by 3 basically. So we will see here the second part of the question. We'll see the second part of the question. Okay, so the second part of the question is we will see the second part. I don't know. Okay, what is the second part anyway? Yeah, we have to find what is the probability that x less than or equal to 0. The probability that x less than or equal to 0 is nothing but fx of 0, which is nothing but 1 by 3 into x plus 1. You will put x is equal to 0 here. So this is nothing but 1 by 3. Okay, next part is the probability that this is the second part. Okay, x minus 5 is less than 1. That means modulus of, this is the probability that modulus of x minus 5 is less than 1. Since we are talking about the continuous probabilities, we are talking about the continuous random variable, this is nothing but the probability that x minus 0.5 is less than or equal to 1. I have already discussed with you this fact. Okay, so what is it? So this is nothing but the probability that x minus 0.5 is less than or equal to plus or minus 1. So this is nothing but the probability that the random variable x minus 0.5 takes the value less than or equal to 1 or between minus 1 and plus 1. Okay, so this is equal to the probability that, so this is equal to the probability that, I will just keep x here, so less than. So you can see here this is nothing but, if you have x minus 0.5, then this is nothing but you will bring this 0.5 on the right side, so it become 1 plus 0.5, so 1.5, and this guy, if you move to left side, this become minus 1 plus 0.5, it become minus 0.5. Okay, so this is nothing but fx of, I told you, if you have something like this, that means the probability that x takes the value between b and a is nothing but fx of b minus fx of a. This is what the formula that we have seen. So this is nothing but fx of 1.5 minus fx of minus 0.5. Okay, so you can substitute it directly. So it will be nothing but 1 by 3, fx of 1.5 is 1 by 3 into 1.5 plus 1 minus next 1 by 3 into minus 0.5 plus 1. Okay, so this answer you will get it as 2 by 3. That means 2 by 3 will be the answer. Okay, or this is 0.666. Okay, that is the answer. So this is nothing but this probability. Okay, probability. Next part of the question we will see now. Next part of the question is yes, x greater than minus 0.5. Okay, so what is the probability that x greater than minus 0.5? So this is nothing but 1 minus the probability that x less than or equal to minus 0.5. Okay, whenever you see the greater than sign, you can rewrite like this. Okay, so this is nothing but 1 minus fx of minus 0.5. So this is equal to 1 minus 1 by 3 into minus 1 by 2 plus minus 1 by 2 means minus 0.5. Anyway, minus 0.5 plus 1. Okay, this is equal to 5 by 6. So this is how to solve this kind of problem. Okay, I hope this is clear to you. So next we will see another problem. It has been given that the CDF of a function of a random variable x is taking this form, fx of x is equal to, so it is ranging from fx of x is starting at minus 1. Okay, it is starting at minus 1. You can see it is starting because before minus 1 the value was 0. So it is starting a non-zero value from minus 1 onwards, starting at minus 1. Okay, now we have to plot the CDF first of all. That's what the first part. Okay, and identify the type of the random variable. We have to find whether it is a continuous random variable, or a discrete random variable, whether it is a continuous or discrete random variable. Okay, we will see it. So it's starting at minus 1. So fx of x, we will plot it. This is your x. So it is starting at minus 1. Sorry, this is minus 1. Okay, before minus 1 the value was 0. Value was 0 here, and at minus 1 to 0, that means this is 0 and this is minus 1. Between minus 1 and 0 it was a constant. You can see here it is a constant like this. It is a constant which is 0.5, and between 0 and 1, this is 1 here. At 1 you can use this value. That means at 1 it will take the value 1 plus 1 by 2, because you have to put here x is equal to 1. So this value will become 1. Okay, so at 1 it is taking a value like this, which is 1 at 1, and between 0 and 1 you can see here it is a line. It is an equation of a straight line. So this is an equation of a straight line which is joining between 0.5 and 1, and after 1 it is always 1. Okay, so this is the CDF of this random variable. Now you can see here your CDF is a constant even before saturating. This is the saturation region. It is saturating here at 1. So before saturation, actually before 1, you can see here this is a constant, and this was 0 here. So this is a constant here. You can see here in the previous problem, whenever you see a constant, it is whenever the CDF is a constant. I will show you the previous problem. So you see here it is again a constant. Here this is a constant. You can see whenever it is a constant, it was a discrete random variable. Okay, so you can see here in our case also it is a constant. So this part is actually showing a discrete random variable, but here it is not a constant, it is a continuous thing, it is changing, okay, and it is continuous. Now you see here it is not a constant, it is a continuous random variable. Whenever it is a constant, I told you it will take a value -1, and between -1 and 0 actually there is no values for the random variable, no values for the random variable between -1 and 0. That is why it is a constant. That's why it is a constant. If there was some value, the probability will be gradually increasing. This concept we have explained already in the previous lecture. So what you can see here, this is a continuous random variable. So it contains both discrete random variable and continuous random variable. So we will call this as a mixed random variable, mixed random variable. So this is a mixed random variable. We can say it is a combination of discrete and continuous. Okay, this is a mixed random variable, okay, or mixed type random variable. So this is what the first part of the problem, that's what the first part of the problem. Next, we have to find what is the probability that x less than or equal to -1. So we have a lot of things now to find. So we will see one by one. So the part B, the probability that x less than or equal to -1 is nothing but the fx of -1. So fx of -1, you know that fx of -1, what is that? Fx of -1, yes, fx of -1 is nothing but 0.5. We have seen this, okay, fx of -1, whenever it is -1, it is 0.5. So you can see fx of -1 is 0.5. So that is the answer. Next part of the question, we have to find the probability that x is equal to -1. The probability that x equal to -1. What is the probability that x is equal to -1? Again, you see here the probability that x equal to -1. What is the probability that x is equal to -1? Whenever we are talking about this x takes the value -1, you see here the probability that x is equal to -1 is nothing but we are talking about a discrete random variable. So since this part is a discrete random variable, the probability that x is equal to -1 is directly obtained from the value itself. So it is nothing but it will be nothing but 0.5, okay. So because it is a constant, that's why we have this at -1. This is like a constant. So this part is a discrete random variable. So for a discrete random variable at -1, at equal to -1, we have some probability. But if it is a continuous random variable, if you take a single point, that probability will be 0, okay. But here it is a discrete random variable at this part, that's why it is having -0, sorry, it is having 0.5. Next, what is the probability that x less than 0.5? So the probability that x less than 0.5 is the next part. So this is x less than 0.5. So we will see what is the situation which is equal to at this region, okay. So this is nothing but, it is nothing but the probability that x less than 0.5 is nothing but the probability that x less than 0.5, you can see, did I make any mistake? No, it's okay, okay. Now this is your 0.5, x less than 0.5, okay, 0.5 is not here, that's it. So 0.5, so at this part is a continuous random variable. You can see this part is showing a continuous part. So I told you about this. So whenever between 0 and 1 you are having 0.5, and this part, sorry, this part is actually showing a continuous random variable. So this part is showing a continuous random variable. So for continuous case, I told you the probability that x less than 0.5 is nothing but probability that x less than or equal to 0.5. It is nothing but fx of 0.5, and fx of 0.5 is nothing but it has been given in the problem 1 plus x by 2. So it is 1 plus 0.5 divided by 2. So you will get the answer as 0.75. Okay. Next part is the probability. What is that? Another part. Okay. Yes, the probability that x less than between minus 0.5 and 0.5. Okay, that is little bit. So probability that x takes the value. The probability that x takes the value between 0.5 and minus 0.5. Okay. So this is nothing but whenever it is less than, so this is nothing but fx of 0.5. Okay. Why? Because this part is in the continuous range, continuous random variable range, and this part is showing in the discrete range. Okay, discrete random variable range. I told you, because you see here between minus 1 and 0, this is a discrete random variable, and from here this point onwards, this is a continuous random variable up to, yeah, it is going to 1. Okay, so this is your fx of x. So that's why. So this I can write in another way also. This is nothing but the probability that, I will use different color, it is nothing but the probability that minus 0.5 less than x less than or equal to 0.5. Okay, because I can write like this because it is a continuous part. This is a continuous part. I cannot write like this. I cannot include the equality because it is a discrete part. Okay, so I can write like this as fx of 0.5 minus the probability that x less than or equal to minus 0. X not less than or equal to, it is less than, sorry, less than minus 0.5. Okay. So because this is a continuous part as I discussed, this is a continuous part I discussed, and this is the discrete part. That's why. So x less than 0.5, the probability is nothing but 0.5. So this minus sign and this is minus sign, and fx of 0.5 we have already got it from the previous problem, because this is nothing but fx of 0.5. So this is equal to 0.75. Okay, this I will substitute here. So you will get it as 0.25. So this is the answer. So the next part of the problem we will see what is it. The probability that x greater than 1. So what is the probability that x greater than 1? The probability that x takes the value which is greater than 1, I think so, right? Greater than minus 1, sorry. That is the problem. That is the question. X greater than minus 1. So what is that probability? For x greater than minus 1, it is nothing but the probability that x less than or equal to minus 1. Okay. So it is nothing but the probability that x less than or equal to minus 1. So this is equal to 1 minus fx of minus 1. Okay, what is fx of minus 1? Fx of minus 1 will be equal to 0.5. So 1 minus 0.5, which is equal to 0.5. Okay, that's it. The next part of the problem is to obtain the probability that x less than 2. What is that? The probability that x less than 2, less than or equal to 2, it is nothing but fx of 2. Fx of 2 is always 1 from the graph. You can see it from the graph. Okay, this is 2, so it's always 1. Okay. Next part is the probability that x greater than 3 So this is nothing but 1 minus the probability that x less than or equal to 3. So this is nothing but 1 minus the probability that x greater than or equal to 3 means that is nothing but it's always 1 here. Okay, so you can see here 1 minus 1, sorry, so 1 minus 1, this will be equal to 0. So this is what the complete solution for this problem. So we will see the last problem. Okay, there are a few more problems in the problem sheet too that we will discuss later. So we will see the last problem here. Now you have a random variable x which is having a PDF which is fx of x which is equal to c into 1 minus x square. Okay, and between the range minus 1 and 1. Okay, between minus 1 and 1. So this notation is actually showing between. Okay, all of you should understand this kind of notations, between, and this is 0 elsewhere. Okay, so there is a so I can actually plot the PDF. Okay, so the PDF fx, so for the first part of the question, find c and plot the PDF. So before plotting the PDF we have to find c. So the find c, how to find c? How to find c? We know that the area under the PDF minus infinity to infinity fx of x dx will be always 1. So this is nothing but integral. It is not starting from minus infinity because our PDF is only defined within this range. This is our range, so it's coming from minus 1 to 1 fx of x dx which is equal to integral minus 1 to 1 c into 1 minus x square dx. Okay, you integrate this thing, so you will get it as 1 is equal to, that means your integral will be equal to 1. So you can find the answer as what is the first part? Actually integral of c is c into x. Okay, it is c into x minus x cubed by 3, that is the integral, and in between minus 1 to 1. Okay, this is equal to 1. So this is equal to c into you will get it as 1 minus 1 by 3, then you will put the limit again. So this is minus 1 minus of minus, so minus 1 minus 1 cube by 3. Okay, so you will get this as c into 2 minus 1 by 3 into 2. So this is 4 by 3 into c. Okay, so 2 by 3, this is 6. Okay, yeah, 4 by 3 into c. So this is equal to 1. That means you will get c equal to 3 by 4. Okay, this is your answer. So you got your c by integration and solving the equation. So your fx of x will be equal to 3 by 4 multiplied with, because you see here it is c, so 3 by 4 multiplied with 1 minus x square between the range x between minus 1 and 1. Okay, and this is 0. So we can now plot the PDF. Okay, this is your x-axis and this is your minus 1 and this is plus 1. Okay, now if you put x is equal to minus 1, so minus 1 square is 1, so 1 minus 1 is 0, so this will be 0. Now when x is equal to plus 1, again you will get 0, and you can see this is a nonlinear curve, so you can fit like this, and if you put x is equal to 0, you will get the value as 3 by 4, and this is a second degree equation. So you can see it is having a bending and it will be symmetric anyway. Minus 1 and 1, it will be looking like this. This is 3 by 4, looking like this. Okay, and sorry, this is your x and this is your fx of x. Okay, that's it. So this is what the first part of the problem, to plot it. Okay, the second part of the problem, the first part is over. Now the second part is plot the CDF of x. Okay, we have to find the CDF next. So what is the CDF of x? This is the question. We know the PDF fx of x is equal to 3 by 4 into 1 minus x square. for x between -1 and 1. This is what we have got from the previous and solution. Yeah, we have got from the previous solution, and is equal to 0 otherwise. Now what is this fx of x? It's nothing but the probability that x takes the value less than or equal to x, which is nothing but integral minus infinity, but it is not starting from minus infinity, it will start only from -1 to x fx of, we will consider the dummy variable t and dt, okay, to avoid the confusion. So this is equal to integral -1 to x 3/4 into 1 minus t square. I am just using the variable t, so dt, okay. If you integrate this, you will get it as 3/4 into the first part become t and the second part become t cube by 3, and you have to put the limit between -1 and x. So this become 3/4 into 3/4 into, you will get the first part as x minus x cube by 3 minus x cube by 3 minus what is it next, x minus x cube by 3, then you will be getting the x minus x cube by 3, then you will put -1, so -1 minus -1 cube by 3, okay. So this will become -1 and +1, so this you will get it as, which is equal to 3/4 into, let me check, okay, yeah, 3/4 into t minus t cube by 3, that means x minus x cube by 3. So x minus x cube by 3 minus of -1 is +1, then this is again minus of minus is plus, then again a minus is there, so this is minus, and again 3 minus is there, so it will become -1/3. So this become 3/4 into x minus x cube by 3 plus 2/3. Okay, 1 minus 1/3 is 2/3. So this is what the PDF of CDF of this, okay, curve. Okay, you will get it as like this. Okay, now we will plot this CDF fx. You can see the CDF will be starting from -1. I told you, because the PDF is also starting from -1, and it will go to +1. At +1, you know that what will be the value. So you can see here at x is equal to 0, fx of 0, you will get it as 3/4 into 0 minus 0 plus 2/3, you will get it as 1/2. So you will get it as 1/2 here. So it will be going like this, and finally it will be going to 1 at +1. At +1, it will become 1 minus 1/3, that means 2/3 plus 2/3, it is 4/3. 4/3 into 3/4, it will become 1. Okay, because at this point you see here it becomes 3/4 into x is equal to 1 minus 1/3 plus 2/3. If you do this calculation, you will get exactly 1. So it is not a straight line anyway. My representation is not good, that's why you will get, it is a non-linear curve. Okay, not a straight line. Okay, it will be a non-linear curve like this. It is not a straight line. Okay, not a straight line, it's non-linear, third order, third degree, because you see here x cube is there. Now this is what the solution for the part B. Okay, so I hope this part is clear to you. Next we will see what is part C. Part C contains a lot of things. the probability that x less than or equal to 0, the probability that x less than between 0 and minus 5, and the third probability as shown here. Okay, now what is the probability that x less than 0? You know that fx of 0, sorry, fx of x, you got it as 3 by 4 into x minus x cube by 3 plus 2 by 3. Okay, that's what I think we have got. Yeah, next, what is the first part? First part is the probability that x less than or equal to 0, and our PDF is between, sorry, our CDF is also between the range from minus 1 and 1. So 0 is definitely between in this range, so it is nothing but fx of 0, which is 3 by 4 into 0 minus 0 by 3 plus 2 by 3. You will get it as 2 by 4, which is equal to 1 by 2. So that is the answer. Now the second part, I will write it. The probability that x less than, x is between 0 and 0.5, and we are talking about the continuous random variable. So this is nothing but the probability that x takes the value between 0 and 0.5. that means less than or equal to can be included because it is a continuous random variable. That's why we have included the equality also here, also equality, because the reason is it is a continuous random variable. So this is nothing but fx of 0.5 minus fx of 0. So fx of 0.5 is 3 by 4 into 0.5 minus 0.5 whole cube by 3 plus 2 by 3. This is your fx of 0.5, and you know this answer fx of 0, you have already got it, fx of 0, which is 1 by 2, so minus 1 by 2. So this is the answer. Okay, I am not going to solve this. Next, the last part, I think so. Yes, next part is the probability that x minus 0.5 is less than or equal to, sorry, not less than or equal to, it's less than 0.25, but it is a continuous random variable. So I can write like this: probability that x minus 0.5 less than or equal to 0.5. Okay, there is no issue for this. So this is nothing but the probability that x minus 0.5 modulus is less than or equal to plus minus 0.25. So this is nothing but the probability that x minus 0.5 is between 0.25 and minus 0.25. Okay, this is what we have seen. So this is equal to the probability that x minus 0.5, I told you this, I will rewrite it anyway, I will rewrite it for the convenience, 0.25 and minus 0.25. So I am rewriting this again, that's why. So this is nothing but the probability that x takes the value between 0.25 is already there, then I will take this to the right side, this become plus 0.5, and if I take minus 0.25 is already there, if I take to the left side it become plus 0.5. So this is nothing but the probability that x takes the value, this become 0.25 and x takes the value 0.75. So this is nothing but fx of 0.75 minus fx of 0.25. Okay, this is nothing but what is fx? The function fx is already given here. So it is 3 by 4 into x is 0.75 minus 0.75 the whole cube by 3, then plus 2 by 3 is there, plus 2 by 3. That's it. This is the first part. Then I will put this minus sign, minus 3 by 4, and our x is 0.25 minus 0.25 the whole cube by 3 plus 2 by 3. Okay, that's it. So this is the answer. I think this answer is coming as 0.2734. I'm not sure, anyway you can check it. Okay, but the method is correct. So I hope all of you understood all these problems. Thank you.